students, welcome to Easy BTech YouTube channel. This channel definitely helps you to understand BTech subjects very easily. So please subscribe, share to your friends. Here I am going to deal the subject signals and systems. This subject is basic subject to understand communications like analog communication, digital communication, and this subject is also helps to understand analysis of control systems. It also helps for studying digital signal processing and also helps image processing, digital image processing. Let's start our session. Today I am going to discuss introduction to signals. Okay, let's start our session, introduction to signals. So before going to the topic signals and systems, introduction to signals, let's see what is signal, the definition of signal, examples of signals, okay, and the basic classification of signals. All those we are going to see one by one. So the definition of signal, it is a physical quantity. It is a physical quantity. Signal is a physical quantity. Physical quantity that varies, that changes or varies with time, space, or any other independent variables. Any other independent variables. Other independent variables. Variables. We can also say like this: physical quantity. Signal is a physical quantity. Physical quantity carries information, that carries or that gives information, that carries information. The simple example I will give you. At present I am talking or I am speaking. So voice signal it is. Information I am giving, I am telling you some information. So quantity that carries information is signal, right? I am giving examples now. What are the examples? Simple examples. Examples of signals. Voice or speech. The music also a signal. Music also signal. Generally music is generated from instruments. Okay, voltage, current, photograph or image, video. So these are all simple examples for signals. Most of the signals, here I am talking about independent variable. The most popular independent variable or most of the signals depends on time. They changes with time. Most of signals This is a point important. Most of the signals changes with time, with the time. So generally time is indicated by letter small t. We use small t, indication of time. So most popular independent variable is time, because most of the signals changes or depends on time. Most popular independent variable is time. Now I am giving one dimensional signal. What is mean by one dimensional signal? Generally we listen one dimensional, two dimensional, three dimensional signals. What is one dimensional signal? What is one dimensional signal? If the signal varies with or depends on, if the signal varies or depends on one independent variable, one independent variable, then that signal is called as one dimensional signal. If you see examples of one dimensional signals, voice is a one dimensional signal, human voice. Voltage, in circuits we write voltage like V of t. So in the bracket you are seeing t, small t, that is time, which is independent variable. How many independent variables in the bracket? One independent variable. So voltage is one dimensional signal. Similarly, current flow in circuits, generally we write as I of t, current flow. So again, current also one dimensional signal. These are the simple examples of one dimensional signals. Next, go to see two dimensional signal. What is meant by two dimensional signal? So here, one dimensional signal, one independent variable, it depends on. Two dimensional signal, it varies with two independent variables, or it depends upon two independent variables. Varies or depends on two independent variables. How many independent variables? It depends on two independent variables. Two independent variables. A simple example for two-dimensional signal is image or picture, photograph. Image. So we represent the image like f of x comma y, function of two independent variables. Here in the bracket you are seeing letters x and y. X indicates x coordinate, y indicates y coordinate. So the image is generally represented as f of x comma y. X and y are independent variables. Here we have two. Next thing, three-dimensional signal. Three-dimensional signal. Three-dimensional signal. What is mean by three-dimensional signal? In the same way, one-dimensional how we define, two-dimensional how we define, as per number of variables, number of independent variables. So three-dimensional signal, if the signal varies with or changes with three independent variables, it depends on three independent variables. Three independent variables. Independent variables. So example for three independent variable signal is moving picture. Moving picture. So this moving picture we represent as f of x comma y comma t. Here x, y indicate or denotes x coordinate, y coordinate, whereas t indicate time. T is time. So this is a about one-dimensional signal, two-dimensional signal, three-dimensional signal. Let's see next basic classification of signals. Basic classification of signals. Very important, this basic classification. Signals are classified. These are classified as three categories. The first one, continuous time signals. Continuous time. The second one, discrete time. Discrete time signals. And the third one, digital signals. Digital signals. See the definition, what is meant by continuous time signal, how they are represented mathematically. So the definition is, if the signal is defined for all values of time, the signal is defined for all values of time, every value of time, all values of time, or every instant of time, every value of time, we can say like this, every instant of time, every value of time. If the signal is defined, then it will be called as continuous time signal. Continuous time signal. We can also say like this, the amplitude, both amplitude of the signal and time, amplitude and time, both are continuous. Or how they are continuous. So what is the meaning of continuous? Continuous means any value. Time can be any value, amplitude can be any value. That is continuous. If both amplitude and time continuous, then continuous time signal. They are represented as or denoted as function of t. Function of small t, the letter small t. Please remember, the letter small t indicates time, continuous time. So x of t, continuous time signal you can say. For example, y of t, you can say continuous time signal. H of t, you can say continuous time signal. Likewise. Next one, discrete time signals. So they are defined only at integer values of time or discrete intervals of time. They are defined only at discrete instants of time or integer values of time. Time must be integer value. That point please remember. Only at integer values of time. Integer value or discrete interval, you can tell. In discrete values or integer values. Or we can say amplitude is continuous. The signal amplitude is like continuous, but time is discrete. The time is discrete. Time like discrete. Discrete means integer value. Then such signal is discrete time signal. How they are represented mathematically? Mathematical way of writing or representation. X of small n, function of small n. Here small n indicates discrete time. In this syllabus or in this subject, if you see small n, that is discrete time. Small t, continuous time. Please remember clearly. So small x of n or x of n, small n, discrete time, or y of n, h of n, like that. Now come to the last one, digital signals. Here amplitude is discrete, like integer values. Amplitude is like discrete, and time also discrete. Time is also discrete. Both are discrete. Both amplitude and time are discrete. Okay. So this is the general classification of signals: continuous time signals, discrete time signals, digital signals. Next thing, important topic is transformations of independent variable. Transformations of which one? Independent variable. Independent variable. Very, very important and easy to understand. Transformations of independent variable. We can also say, or it is also called basic operations on independent variable. Basic operations on independent variable. Independent variable. Most popular independent variable is, what is the most popular independent variable? Most of the signals will depend on time, small t. So now basic operations on time or independent variable. So three basic operations we have. Three basic operations. The first one, time shifting. Time shifting. The first operation or transformation. Time shifting. The second is time scaling. Time scaling. Second transformation or second operation. And third one, time reversal. Time reversal. Let's see one by one what is time shifting. So to define this basic operations on independent variable, I am considering a continuous time signal x of t. Consider continuous time signal x of t. Now time shifting of x of t. Time shifting of x of t. What is time shifting of x of t? X of t plus or minus t naught. This is called time shifting of x of t. X of t plus or minus t naught. Here the letter t naught indicates amount of time shift or number of units we are shifting the signal. How many units we are going to shift the signal, or amount of time shift, amount of shift. And the plus symbol, minus symbol. The plus indicates left shift of the signal. We can shift the signal towards left, we can shift the signal towards right. So that left shift, right shift is separated by plus minus symbols. Left shift. And the minus symbol is right shift. Right shift. Okay. This is about shifting of the signal, time shifting. This left shift we can also call advanced. Signal is advanced, as advanced version of the signal. This right shift we can also call delayed version of the signal, or signal is delayed. Time scaling. X of t is a continuous time signal we have taken, we considered. Its time scaling is x of t, time scaling is x of at. X of at. Here the letter A indicates scaling factor. It indicates scaling factor. If A value like 0 to 1, it is between 0, 1, like 1 by 2 or 1 by 3 or 1 by 4. A value is between 0 and 1. If A is like this. In this case, or in this situation, the signal is expanded. If you take A value 0 to 1, signal gets expanded, or expansion, signal expansion. The result is signal expansion. Another case of A value. If A value is like more than 1 or greater than 1, A value is more than 1, like 2, 3 and so on, then the result, the signal is compressed. The signal is compressed in this case. Signal compression, we call it as compressed or compression. So we can expand the signal, we can compress the signal. This operation is called time scaling. By choosing A 0 to 1, between 0 and 1, signal expansion, we get more than 1, signal is compressed. Now time reversal. Already x of t is considered. Then time reversal of x of t, time reversal of x of t is x of minus t. X of minus t is called time reversal of x of t. Again, if you want time reversal of x of minus t, time reversal of x of minus t, I want to time reversal of x of minus t. What is x of minus t time reversal? It is x of t. Okay. This time reversal operation we can also say folding of the signal. You can say folding of the signal. Okay. Now, in the similar way, we can take discrete time signal. In the same way, we can take discrete time signal x of n. Now, the discrete time signal x of n, the independent variable is small n, right? Discrete time, small n. Now, time shifting of x of n, what it will become? Time shifting of x of n is x of n plus or minus n naught. N naught indicates amount of shift or units of shift. Plus indicates same way left shift, minus indicates right shift. Now come to time scaling. So the time scaling of discrete time signal x of n is x of an. X of an. In the same way, if you take a value between 0 and less than 1, signal is expanded. More than 1, signal is compressed. Now time reversal. The time reversal of discrete time signal is x of minus n. X of minus n. Now we are going to see one example problem. Okay? Example problem we are going to see. That problem, in that problem, time shifting, time scaling, time reversal we are going to perform. Let's take that problem. Consider g of t, given g of t. Consider the signal g of t. Just I am plotting the signal, given signal g of t. So it is available 0 to 2. So here x-axis is time and the y-axis is the given signal g of t. The amplitude is 4. Okay. Now asking draw the first thing g of minus t, and the second thing draw minus g of t, and third one g of t minus 1, and the fourth one g of 2t. Okay. Now first of all, the given signal is a continuous time signal or discrete time signal? That is a question mark. The given signal is continuous time signal or discrete time signal. It is continuous time signal. Here the letter small t, x-axis, continuous time, and the given signal is continuous time signal. Now go to the first one, time reversal. G of minus t, what we call time reversal or not? G of minus t indicates time reversal. So how to perform this time reversal or folding? See how I am doing. Only time is reversed. Amplitude is as it is. No changes in amplitude. These are all operations on time. Transformations of time. Right? Minus t, time. And here t minus 1, time here 2t time, but here the second one is amplitude reversal. The signal is multiplied by minus sign. G of t is multiplied by minus sign. That is called amplitude reversal. That we can see, no problem. First see g of minus t, time reversal of g of t. So here I am reversing the time. So x-axis t. The given signal is between 0 and 2. Between 0 and 2. So 0 reverse is 0 only. 2 reverse minus 2. I am doing time reversal minus 2. And what about signal amplitude and signal shape? As it is, there is no changes in amplitude, only time reversal. Only time reversal. So what is the amplitude? At 2, how much is the amplitude? 4. At 0, what is the amplitude? 0. So amplitude values are same. At 0, take the amplitude 0. So time reversal, plus 2 will become minus 2. At minus 2, the amplitude is how much? 4. Amplitude is 4. So that I am plotting. So now this is g of minus t, folding of g of t. I think clear. Now second one, the total signal is g of t. The total signal is multiplied by minus sign. So this operation is not belongs to independent variable time. It is belongs to amplitude, value of the signal. So originally the value of the signal is 4, and it is the signal is available from 0 to 2. So the result of this, I am drawing. X-axis is t. X-axis is t. Where to where the original signal is available? 0 to 2. So now this is y-axis. Okay. So 0 to 2, the original signal is available. Now at 2, the amplitude is 4. So now here it will become minus 4 at 2. So take minus 4. How much? Minus 4. So this is the result we get. Amplitude is reversed now. If you compare the result with the given signal, amplitude is reversed. Only amplitude is reversed. Everything same. Time is no changes. 0 to 2. Here also 0 to 2. Amplitude is plus 4. Now it is downwards minus 4. Because of minus sign. You are multiplying the amplitude by minus sign. Plus 4 will become minus 4. That's all. Now g of t minus 1. So this is time shifting operation. The third one. Time shifting operation. How much the signal is shifted? 1 unit. Amount of shift 1 unit. Towards right or left, the minus sign indicates right shift. So the signal is shifted right, shifted right 1 unit. 1 unit. That means the 0 shifted to 1 unit. We need to shift every time value shifted right 1 unit. So 0 plus 1, 1, and 2 plus 1, 3. 1 unit I am shifting right. So 2 plus 1, 3. So the resultant or the answer is, the signal is from 1 to 3. 1 to 3. The amplitude is same 4. This is called g of t minus 1. 1 unit shifted right side. Now you compare, the original signal started 0, now it is started from 1 second. It is ended by 2, it is now 3 because shifted right side 1 unit. So every time instant or every time value we need to shift right by 1 unit. Simply add 1 to the original time values. Right? This is the third one. Next, the fourth one, g of 2t. So this is called time scaling of g of t. Time scaling of g of t. So already we discussed what is time scaling. X of at. A indicates scaling factor. So here what is the a value? The a value is equal to 2. Scaling factor is 2. So if a value is more than 2, signal get compressed. Sorry, more than 1, not 2. If the a value is more than 1, signal is compressed. So here also compressed signal we get. How much factor it is compressed? 2. So now I am doing that signal compression by factor 2. So here x-axis is t. Now 0. So 0 by 2. Compression means we need to divide the time by the factor 2, because here 2t we want. So I am doing that. 0 by 2 is 0 only. So no need to write 0 by 2. Similarly, every instant, time instant of the signal we need to compress, we need to divide. We need to divide. Here we have 2. So now 2 by 2 it will become 1. So this is the result. So the resultant signal is between 0 and 1. This is the resultant signal. The amplitude no changes. Amplitude is as it is 4. So this signal is called g of 2t. Compressed or not? Compressed. How much? Factor 2. The original signal is 0 to 2. Now here 0 to 1. Compressed by factor 2. This is fourth one, g of 2t. Okay, I think these 4 operations I am clear. Okay, so students, please subscribe, share to your friends, very helpful to you. So please subscribe, share the channel. Thank you. We will be having next session. Thank you all.